a give the products problem. Let's imagine that we start with this ketone, cyclohexanone. And then in this particular case, instead of using 2 molecules of an alcohol, let's use 1 molecule of a diol. In other words, within this 1 molecule, there are 2 alcohol groups. And then we will say we are going to add a catalytic amount of acid. And then the other thing we'll say is that we will somehow remove any water that forms. This could be done by adding a dehydrating agent like magnesium sulfate, or in lecture we discussed 4 angstrom molecular sieves, for instance. Just some way of removing the water that is formed. So see if you can write the product. Focus again on the carbon of the carbonyl. That is the carbon that's going to be converted into the corresponding acetal. And the new wrinkle to this is that both ROHs that you're going to use to make your acetal are within the same molecule. So write the product. In the product, there's going to be a new bond between this oxygen and the carbonyl carbon, and between this oxygen and the carbonyl carbon. And then the elements of water, which we are going to remove, are these 2 protons and this oxygen right here. So if you didn't write the product, if this helps you, please go ahead and pause the video and write it now. On the product side, here's the carbon that was the carbonyl. It's now going to be the acetal. Remember, in acetal, there are 2 oxygens bonded to the carbon. So if we keep track of which oxygens were those, here they are, here and here, and here and here. So again, if you've been stymied by this problem, keep on trying. Pause the thing, see if you can finish off the product. In the product, those 2 oxygens are connected by a 1 carbon, 2 carbon unit. So there we go. There's the final product. This is the acetal. Notice, because we use this diol as the source of our 2 ROH groups, there's this additional ring in the product. And it kind of looks like a little face here, you know, here are the eyes and everything. So this type of acetal group is often used when one wants to, for instance, protect the carbonyl group of an aldehyde or a ketone. And we'll talk about protecting groups a little bit later in lecture. So there's the product.